everyone, welcome to Smart Math Online Tutor. Through this video, I'm going to tell you about angles in a polygon. So let's get started by looking at what is a polygon. In smaller grades, you have already learned that a polygon is a closed plane figure bounded by straight line segments. So according to the number of sides a polygon has, you can give the polygon different names. If a polygon has 3 sides, you call it a triangle. If it has 4 sides, it becomes a quadrilateral. If it has 5 sides, we call it a pentagon. And if the polygon has 6 sides, we call it a hexagon. Whereas a polygon with 7 sides is called a heptagon, and that of 8 sides is called an octagon. So these are the basic polygons that you have already learnt. So let us see more about angles of a polygon. First of all, we are going to study about the interior angles of polygons. If you take a triangle, in small grades, you have learned the sum of interior angles of a triangle is 180 degrees. So if this is 180 degrees, with this knowledge, we are going to find out the sum of interior angles of the other polygons. Now let's take a quadrilateral. Now here it's a quadrilateral. I have divided the quadrilateral into triangles. So if you divide the quadrilateral into triangles by joining its vertices, you will find out that the quadrilateral can be divided into 2 triangles. So if the sum of interior angle of one triangle is 180, the sum of the interior angles of a quadrilateral will be 180 into 2 because it has 2 triangles, and therefore the sum will be 360 degrees. So this is a very easy trick. If you can't remember what is the interior angles or the sum of interior angles in a polygon, simply you divide it into triangles. Now look at this. This is a pentagon. So I have divided the pentagon into 3 triangles. Then the sum will be 180 into 3, that is 540. And look at this hexagon. A hexagon can be divided into 4 triangles. So its interior angle summation will be 180 into 4, that is 720 degrees. So whatever the polygon you get, all what you have to do is to divide it into triangles. And when dividing into triangles, you should remember the lines you join, the vertices must not intersect, right? You can't draw one line and draw another which will cross that line. So that point you have to keep it in your mind, and then we can conclude the fact the sum of interior angles is equal to 180 degrees into number of triangles. Fine. Now this is one method, and there's another method. An equation is given. The sum of interior angles of a polygon with n sides is equal to 2n minus 4 into right angles. Now look here. The number of sides in a polygon is 6. The sum of interior angles is what? So we know the equation, that is equal to 2n minus 4 times right angle. So let's substitute. Instead of n, it tells there are 6 sides. So instead of n, we put 6. 2 into 6 minus 4 times 90. 2 into 6 is 12. 12 minus 4 is 8. 8 into 90 is 720 degrees. So using this equation as well, you can find out the sum of interior angles of a polygon. Right. Now that is all about interior angles of polygon. Let's look into an example. Find the value of x. Right. Now here a pentagon is given. The 3 angles each of 100 degrees is marked, and 2 angles are marked as x, and we are going to find out what is the value of x. So first of all, let us write down the equation. Sum of interior angles of a pentagon we know is equal to 540 degrees. And then we can write down the sum of interior angles. I write as 100 plus 100 plus 100, and 2x is equal to 540. Let's subject 2x, then it becomes 540 minus 300. That is equal to 240 degrees. So if 2x is equal to 240 degrees, you know x will be 120 degrees. So this is how we apply the equation in a sum. Right. Now we are going to look into the sum of exterior angles of a polygon. Now look at this polygon. This is a quadrilateral. I have extended the sides of the quadrilateral and marked the exterior angles as A, B, C, D. So these are called the exterior angles of a polygon. Any polygon, if you extend the sides, the angle forming outside the polygon is called an exterior angle. So you should remember, in case of exterior angles, all the polygons will have a sum of exterior angles which is equal to 360 degrees. Whatever the polygon, the sum of exterior angles will not change. Though the interior angles vary, the sum of exterior angles will be always 360 degrees. So in this case, you don't need to bother about what is the type of polygon. You have to just remember exterior angles of any polygon is equal to 360 degrees. So in this case, I can write down A plus B plus C plus D is equal to 360 degrees. Right. Now let's look into an example. Find the value of unknown angles. Now here this is a pentagon and some angles are given, some angles are not given. So with the given details, we are going to find out the values of A, Y, P and X. First of all, I am starting with this angle, this place. This is a straight angle, it's a straight line, so I can write down 80 plus y is equal to 180 degrees because it is a straight line, and thereby I can find out y is equal to 100 degrees. So remember to write down the reason within brackets when you write any statement. Right. Next, I'm going to move on to this place. There again, the same theory. 100 plus P can be written as 180 degrees because it is a straight line. Then I can find out P to be 80 degrees. Fine. Then I am moving on to the next straight line. That is this. So then I can again write down 110 plus X is equal to 180 degrees. Once again, because it is a straight line. And therefore, I find out X to be 70 degrees. This X I found how? 180 minus 110, right? So it is 70 degrees. Now I have found Y, P and X. So A is to be found. To find A, I write sum of exterior angles is equal to 360. So I can then write down A plus 80, that is this 80. And then P plus X plus P is equal to 360 degrees. So now I'm going to substitute the values I have already found, and only A is to be found instead of P. Both the P's will be equal to 80 degrees. And then once when you subject A, you will get A is equal to 360 minus 310. So A becomes 50 degrees. So this is how you work out with exterior angles of a polygon. Fine. And then we are going to move on to the last section, that is magnitude of an exterior angle of a regular polygon. Now, first of all, you should remember what is a regular polygon. A regular polygon is a polygon with all the sides and angles equal. So, all the sides must be equal and all the angles must be equal. One of the best examples at once I can give you is the square. You know, in a square, all the sides are equal. That is very obvious. And at the same time, you know, all the angles are 90 degrees. So, the square is a regular polygon. Now, here, what are we going to find out is the magnitude of an exterior angle of a regular polygon. You know, the sum of exterior angle of any polygon is equal to 360 degrees. So, we can derive an equation like this. Magnitude of an exterior angle of any polygon is equal to 360 divided by the number of sides. In a polygon, you should remember the number of sides and the number of angles will be always the same. So, if you divide the number of the sum of exterior angles by the number of sides, you will get the value or the magnitude of one angle. So let's see whether this can be applied in an example. Now look at this example. Find the magnitude of an exterior angle of a regular polygon with 12 sides. Now in this case, you should remember this 12 is the number of sides. And then magnitude of an exterior angle, this is the equation, 360 divided by number of sides. And then we write down the values substituted. Instead of number of sides, I have put 12 here. And 360 and 12 can be cancelled. In 36, you have 3 12s and this 0 we write as it is. So the answer becomes 30 degrees. So this is how you find out the magnitude of an exterior angle of a regular polygon. You should remember this can be applied only to regular polygons. So hope I made myself clear regarding interior and exterior angles of a polygon. See you with another smart math tip. Until then, goodbye.